A spacecraft travelling to the moon consists of two parts, a lunar module used for landing on the moon and a re-entry module used for returning to Earth. Both modules are connected by an airlock. 80% of the time, the astronauts are all in the same compartment and the airlock is closed. The astronauts are in the lunar module for half of this time and in the re-entry module for the other half. If a meteor strikes the module containing the astronauts, or while the airlock is open, then the astronauts will die. If the astronauts are in the re-entry module and the meteor hits the lunar module, then the astronauts will jettison the lunar module and return safely to Earth. If the astronauts are in the lunar module and the meteor hits the re-entry module, then the astronauts need to get into their spacesuits and try to make repairs. They have a 40% chance of being successful at making these repairs. Otherwise, they have no way of returning to Earth. Draw an event tree for the event that a meteor hits the spacecraft and determine the probability that the astronauts will return safely to Earth. Okay, so this time we're going to draw an event tree. Now, we've got 4 events that we're interested in, whether the airlock's open or closed, whether the astronauts are in the re-entry module or the lunar module, where the meteor actually hits their spacecraft, and whether the repairs work. Now, one thing you'll notice is if the airlock is open, it doesn't matter where they are, they die. So therefore, airlock open doesn't have any more branches. So if we put it over on this side, we'll have to put it multiple times. But if we put it here, we just simply have a branch that doesn't go anywhere and it's much simpler. So we're going to start with that. Now, out of what we have left, we've got astronauts, where the astronauts are, and we have where the meteor hits the astronauts, and whether the repairs work. Now, we can't put the repairs early in this picture because they only actually happen if the astronauts get to the point where they can do them. So we know they're going to be over on this side. So we've got where the astronauts are and where the meteor hits the asteroids to go in the 2 middle events. Now, the next issue is, it doesn't really matter which one. Whether they're in one place and then it hits them, or whether it hits a certain place and they're in there, it's going to be the same effect as far as our calculations go. So let's put it that they're in the re-entry module as our first event. Or in landing module. Then we'll break this one up. Either the meteor hits where they are, or the meteor hits the other module. And down here we have the corresponding events. Either the meteor hits the landing module, or the meteor hits the re-entry module. Now, if they're in the re-entry module and the meteor hits the re-entry module, that's it. We're finished. Because they are in a bad shape. So don't return. If they're in the re-entry module and the meteor hits the landing module, that's okay. They can go to the moon, come back, just like they did in Apollo 8, and they'll be okay. So they return. If they happen to be in the landing module and the meteor hits the landing module, it's all over. On the other hand, if they're in the landing module and the meteor hits the re-entry module, well, now the question is, can they go from where they are in the safe area of the landing module to fix the re-entry module? So now we have the question of whether their repairs work or whether the repairs fail. So if the repairs work, they get to come home. And if the repairs fail, well, we always did say it was dangerous. Okay, so now we can start putting our numbers in. So we said that the airlock would be closed 80% of the time because they're worried about this risk, so they're trying to minimise it by keeping the airlock closed, which must mean that it's open 20% of the time. The probability that they're in the re-entry module, we've said it's 50-50, whereabouts they are. And then where the meteor hits, we've said that that is 50-50 as well, because they're both approximately the same size. Now, the repairs, well, it's going to be difficult work, probably more likely to fail than succeed. So we said 0.4 that it works and 0.6 that it succeeds. Okay, so now we've put in all our data, we need to do our calculations. The things that we care about are this one and this one. These are the cases where they make it back. So what we've got is we've got 0.8 times 0.5 times 0.5. So this gives a quarter of 0.8 gives 0.2. So we have 0.2, 20% chance that they'll be able to come back without too much difficulty. For this one down here, we've got more steps. We've got 0.8 times 0.5 times 0.5, but this time there's the added steps of the repairs. 0.8 times 0.5 times 0.5 times 0.4 equals, well, it's the same as this, 0.2 plus we've got to multiply by 0.4, so we get 0.08. So we now, to get the total answer, we add together all of the cases that we're interested in. So we've got 0.2 plus 0.08, which equals 0.28. So if a meteor actually hits the spacecraft, there's only a fairly small chance that they're going to be okay. However, we're hoping that this doesn't happen very much, and so there's a big chance that they'll be okay.